Welcome to Design and Analysis of Algorithm lecture. The key concept of the lecture is that problem. Can the problem be solved? How difficult is the problem? Real life problems to algorithmic problems. Then about the algorithm, how to find suitable algorithm, how to make it efficient. The third thing is instant, upper and lower limits for knowing the instance. Then is about the graph problem. Basically the graph problem is of three examples has been given: coloring problem, the shortest path, and traveling salesman problem. So the coloring problem is that we can color on the particular area in the graph and we can find the solution. The shortest path and traveling salesman problem deals with finding the shortest path from source to destination. The next is what about the algorithm. An algorithm is that when we need a well specified problem that tells what needs to be achieved, then that can be solved using the algorithm. That algorithm should be unambiguous statements, and it consists of a sequence of commands that takes an input and gives output. See that when an input is given, the algorithm should solve the problem and it has to give the output on a particular time. The algorithm principles. The algorithm principle is divided into three: the sequence, condition, and loops. And the sequence will be that one command can be executed at a time in the algorithm. Then it can be based on parallel and distributed computing. The condition is that you can use in an algorithm some conditions for solving the algorithm, that may be if condition or switch cases. Loops is that we can use some recursive loops inside the algorithm. The algorithm may be recursive or non-recursive, but we can use the loops like for, while, and repeat. There are basically two types of complexity to understand the algorithm. One is that time complexity. The second is that space complexity. Time complexity means that how much time the algorithm takes to compute the particular problem. That is called as time complexity, and it is measured by a function t of n. The space complexity is that how much memory it takes to compute. That means the space required to store the algorithm. That is called as space complexity, and it is measured by a function s of n. Basically, the function which is given in the previous slide, t of n, is said as n is equal to the size of the input, t of n is equal to time complexity function, and the order of magnitude for this time complexity is that how rapidly t of n grows when n grows. That means when the input size grows, how much efficiency is getting improved or getting drastic for t of n function. For example, big O of n or big O of log n, big O n square, or big O of 2n. These are some of the time complexity functions. Thank you.